In this example, we're going to use the slope-intercept form of a linear equation to state both the slope and vertical intercept for this equation. We'll then interpret what each means in the context of this model. We'll also calculate the horizontal intercept of this equation and interpret what it means in the context of this model. You'll note that in this example, we're referring to a general vertical intercept and horizontal intercept instead of a y-intercept and an x-intercept. That's because the variables we're using are t and h instead of x and y, so we'll refer to them more generally as vertical and horizontal intercepts. So we're told to assume that a commercial airplane is traveling at a constant speed and angle. When it starts descending, its height h, which is measured in feet, after t minutes can be modeled by h equals negative 600 t plus 30,000. So to state the slope of this equation, we'll look at the coefficient on that variable t, which is 600. So our slope here is negative 600. In order to talk about what this means in the context of this model, there's two things that we want to note. The first is that the slope is negative, so we're going to be talking about something decreasing. And the second thing we'll want to look at is the units. So every time t increases by 1 unit, h is going to decrease by 600. And I know that based on this idea of the slope being negative 600. So thinking of, I'll write that down real quick. Every time t increases by 1 unit, h decreases by 600. Okay, and my units are minutes and feet. So in context, that means that as every minute passes, the height decreases by 600 feet. So I'll say, in context, each minute that the plane descends, its height decreases by 600 feet. Okay. The next thing we're going to look at is the vertical intercept. And I've written here that in this case, this is the h-intercept. So looking at h equals negative 600t plus 30,000, when t is 0, the value of h will be 30,000. So the vertical intercept is then 0, 30,000. And if we want to write down when t equals 0, h equals 30,000, we can. That can be helpful in terms of talking about the context of this model. Okay, when we talk about the context, we'll make sure and include our units. So t equals 0 is when the plane starts descending. We're told that it starts descending, and this model is talking about after t minutes. So when t is 0, that's when it very first starts its descent. So, and then h equals 30,000, that's the height in feet. So in context, we'll state the height of the plane is 30,000 feet when it starts its descent. Okay, and in the next one, we're going to look at the horizontal intercept. And that's going to be where h is 0, and we're going to solve for the value of t. So solving that, I know that h needs to equal 0, and so I'll have negative 600t plus 30,000 equaling 0. And so to solve that equation, I'll want to solve it for t. And I can add 600t to each side to get 30,000 equal to 600t. And then I'll divide each side by 600. And that will give me 50 equal to t. So when h is 0, t is equal to 50. That tells me then that the horizontal intercept is the point 50, 0. Now, when the height is 0, the time is 50 minutes. So, in context, we could state that. After 50 minutes, the height is 0. We could also state that the plane lands after 50 minutes. So, and I'm going to stick with the height is 0. In context, the height of the plane is 0 feet. After 50 minutes.